Good morning, folks. This is Mr. Dan coming to you from the Landscape Design Classroom. And today I'm going to talk to you about hydroponic growing media. So, main idea here, what can be used to replace soil in a hydroponic system? So what we've reviewed from lessons from before is hydroponics is usually typically a water-based system, but there's actually a few different ways that you can do that. So if we take a look at the picture from the bottom here, we're using water in a hydroponic system that would be more of an aggregate that uses stone. So growing media, soil provided by nature. It's used for most agricultural and horticultural crops. So if you see any fields out anywhere where you live with some crops growing, like corn or soybeans or anything like that, you're typically going to find that those are in a different type of soil, or anything in the ground would be in soil. So soil contains organic matter for decomposed remains of plants, animals, and their waste products. And these are great for growing stuff in soil because it offers texture and fertility through different nutrients and other things. So hydroponic media is any substance in which plant roots can grow and develop. Now, it must provide oxygen, water, nutrients, and support for plant roots. So whenever you take plants out of soil and you're using them in a hydroponic system, you need to make sure that you're replacing those with the proper nutrients, media. And like I say in every presentation I give on greenhouse and hydroponic subjects, make sure you're reading labels and doing your research on the plants you want to grow. Examples of soilless hydroponic media. So we have water, gravel, sand, sawdust, hydrogen stones, horticubes, rock wool, and there's actually a few other things you can look into as well. So if we take a look at the picture here on the right, these are rock wool cubes. So I haven't worked with these in a really long time. The system we will be using in this class is water-based. So we'll be using PVC pipes in a horizontal fashion with holes in the top that will be circulating water through over and over again with all the nutrients and that good stuff. So choosing a growing medium, you always want to look at what's available. So we have a really cool looking rotary hydroponic system that continually shifts around all day, getting those water and nutrients into the system. Like I said, ours is going to be a PVC unit. You want to look at the cost, plants being grown, quality of material, type of hydroponic method or system. And just to touch on that again, whenever you're getting into these systems the first time, I recommend keeping your costs down just to see if you really want to get into this method of growing or not. It can be very fruitful at the end of the day if you really get into it, because typically plants that are grown through hydroponic systems tend to be healthier for you. So, three main methods of hydroponic production. We have water culture, aggregate culture, and aeroponic culture. We're going to touch on a little bit. We're going to touch on each of these a little bit. So, water culture. This is growing medium. It's nutrient solution. So, like I always tell you, make sure you read your nutrients read the label on your nutrients and do your research into how much nutrient you're going to be putting into that system. Roots immersed in continual nutrient solution flow, and supports for plants, tops and stems. So as we can see here on the picture to our right, we have plants being used in a styrofoam material into this water solution, and the roots growing through the bottom of it. So you need to have that support to ensure that your plants are staying upright. Well aerated nutrient solution. So whenever they put this little thing down, or this piece of styrofoam, it's probably going to sit a little bit above that water. So that roots are going to get down in there, and in that solution, it looks a little bit brown, but that's all the nutrients going around in there. So it's a nutrient-based water solution. So moving on, aeroponic culture. Nutrient solution sprayed or misted on the roots of suspended plants. So these are typically towers. This is much more costly to run one of these. You're using a lot more electricity to run the water up and down those. There's very little growing medium though will be needed. So these plants coming out the sides, typically you might find them in the soil, but for the most part, you're gonna find those a little bit more of a airy solution, or even with a styrofoam. And increased oxygen to the plant. So see, having all these little holes poking out is giving maximum oxygen to that plant coming through. And then having a continuous water flow on the inside, that water is actually going to pump some oxygen up in there too. And then uses less water. So these systems are extremely efficient, but like I said, they are pretty costly. The drawbacks of aeroponics: mineral buildup on misting nozzles. So when you get that buildup, it's going to block stuff coming out of those nozzles. So you need to make sure you're cleaning those regularly. More vulnerable to plants drying out. So if you have a lot of air coming in, typically your plants are going to dry out quicker. So you need to constantly doing maintenance on these to ensure that they are not getting aired out. So making sure there's water on the inside, really keeping those guys hydrated. May need more management. Typically these systems do require a little bit more management. While they use less water, you want to make sure you're still getting them the right amount of water, and you want to be cleaning those nozzles, like I said before. Now, moving on into aggregate culture. We have a vertical hydroponic garden with 9 tomato plants in the space of 1. So using these systems, you can actually have a lot more room for plants. In this class, the system we're going to be using is a PV sealant one, like I said, and that irrigation system will turn to drip over time once plants get too big for our hydroponic system. So the growing medium for an aggregate culture is solid material. Selection is based on growing method, flood irrigation for coarser to medium growing material, and trickle irrigation for the finer to medium growing material. So typically using an aggregate is going to be more of a stone. So you want to make sure you have something that is pretty solid and can grow up through, but you don't want to have it so solid that you're never going to have a root system grow into it. So aggregate cost and availability, less expensive for local media. So using sawdust and bark in timber producing areas, local sand and gravel, peat mixes. We'll be using a pro mix back here whenever we do an aggregate one later this year. And then man-made choices, rock wool, perlite, hydrogen stones, and vermiculite. So any of these man-made ones are going to be a little bit more costly to get in, but at the end of the day, it's still, you're going to end up with a little bit better product that's cheaper than using on an aeroponic or using an aeroponic unit. So aggregate quality, ideal characteristics: they're chemically inert, non-toxic, and free from plant pathogens. Limestone can affect pH. Typically, you want to throw lime in there if you want to get your pH up. So just remember that you want to have a pH of 6.0 to 6.5, which is just slightly acidic. So throwing too much lime in there will turn your plants a little more alkaline and will stunt the growth. So like I always say, read the label, do your pH testing, and ensure that you're doing the right things for your plants. So beach sand and sawdust, they may be high in sodium chloride. So you want to watch how much you're putting in there. So a little bit too much sodium will kill plants off. And then harder aggregates offer more durability. So if you have something that's pretty solid that's going to let some roots through, that's probably going to be really good for that plant. So consider moisture retention. The most important characteristics of a growing medium. So too much moisture retained is poor drainage and low oxygen movement. So if you continually have water going through, you're going to have really good oxygen movement going through there and getting that air down into the roots. Too little moisture retained, crop moisture stress, and possible crop death. So you need to get that moisture in there. Water is one of the most important things you can get to the plants, water and air. So if you can continually have those flowing through there over your roots, then you're going to have good growth. So some other factors, before I get into this, if we take a look at the picture here on the right, those little white particles or perlite, those are going to help your soil get some air down into them. So aggregate size, small particles closer together, more surface area, larger particles farther apart, less surface area. So Depending on the size of your particles, it's going to really depend on how your roots grow and where your plant comes out from. So if you have, it can be more controlled with larger particles, but having those smaller particles will let your root system grow and expand a little bit more. And surface shape, irregular shape retains more water. Regular shape retains less water. So a little more on water retention. Porosity, which means porous, which would be a vermiculite or perlite. They're going to hold more water, and hard or smooth, which would be granite, it's going to hold less water. Drainage, large particles drain well, but may not hold moisture for hot, sunny days. And fine particles tend to puddle, holding excess moisture. So it's really finding that delicate balance of getting in the right amount of air and water. So it all depends on the crops. So research what you're doing with your crops. Combining aggregates, a combination of different sizes is good for moisture retention and good drainage. So irrigation, more needed with smooth, regularly shaped coarse aggregates, and less needed for porous, irregularly shaped fine aggregates. So if you have regular shapes, you're going to need a little more irrigation, less shape. More irregular shapes are going to require less. So talking about hydrogen stones, these are clay pebbles. You can see them down here in the bottom of the picture and around the plants. They are considered a coarse aggregate, so made from lightly expanded clay. So they're going to hold some moisture and they're going to give some in there. Typically marble size, lightweight, used in beds, Dutch buckets, and aquaponics, and popular with smaller growers. So these hydrogen stones are generally popular with smaller growers because the cost is a little bit cheaper and they last a little bit longer. Managing the growing medium. Problems over time, aggregates break down, microorganisms build up, and roots taking more space. So in the long run, roots are going to take form and they're going to take up a lot of space. So you want to make sure that you're offering enough space within that growing medium for roots to expand, especially depending on what type of plant or vegetable you're trying to grow. So make sure you're always checking for breakdown aggregates and adding more in as needed, and always be testing to see what kind of microorganisms are in there. Even like take it on a petri dish and take a look into it using a microscope to see what you might have crawling around in there. So some possible solutions: changing the medium and sterilizing the medium. So cleaning and changing medium is a good thing. So you don't have to do it as much with a hydroponic system, but I typically like check my stuff daily to see when it needs done, because to optimize your growth means to optimize your profit at the end of the day. So two common sterilization methods. We have steam sterilization and chemical sterilization. Steam sterilization is a perforated steam line covered with canvas. It's a steam generator, a growing medium reaching 180 degrees Fahrenheit for at least a half hour. So whenever you reach that, that means you're sterilizing the material. In chemical sterilization, several possible chemicals. Many are highly toxic, may require a PA pesticides license or from your respective state, and maybe other restrictions. So if you can, I would definitely recommend a steam sterilization over a chemical sterilization, but depends on what you have available and what the cost is. So application followed by rinses and airing out of greenhouses. So whenever you are using chemicals of any kind, you need to make sure, especially if it's something that can affect you through smell or by touch, that you are getting cleaned up afterwards and you are airing out your greenhouse. Removing accumulated salts, build up from fertilizer salts. Any system is going to get some sort of salt in it, so you want to make sure you are cleaning those out over time. Clean water rinse growing media every 2 weeks. So that means taking the water that's currently in there, removing it or getting rid of it, and running clean water through there every couple weeks to get that system cleaned out. And the bottom line here is many different plant growing media substances are used in place of soil. Selecting which medium to use in a hydroponic system depends on the growing system, crops being grown, and moisture retention. So that is the end of my presentation. If you have any questions, you can contact me down here in the landscape design classroom, but I appreciate your time and have a great day, folks.